In this video, we will explain the basics behind the Harris corner detection algorithm. The concept is rather simple. We want to build on edge detection theory in order to find corners in a picture. Let's consider a small frame from a picture. This can usually be divided up in three regions: the flat region, the edge region, and the corner region. Now let's say we want to find this corner. We know from edge detection theory that we can identify the vertical and horizontal gradients in a picture. If we have a large horizontal gradient, we have a horizontal edge. And if we have a large vertical gradient, we have a vertical edge. This in turn means that if both the vertical and horizontal gradient is large, we detect a corner. Usually, however, corners are not perfectly aligned in the x and y direction. So, in order to detect a corner here, we need a way to rotate the corner back so we can use the information we get from the gradients. This can be done by a simple eigenvalue evaluation of the structure tensor. The structure tensor is a matrix that uses a different method of representing the gradient information, which is a more precise description of the local gradient. By finding the eigenvalues, and if these are positive and large, we have found a corner. Now, after calculating the gradients, we can apply a simple averaging filter in order to remove noise from the picture. The most used is a Gaussian filter. In order to avoid calculating the eigenvalues of the matrix, the following method is used as suggested by Harris and Stevens. Let's move over to the MATLAB script. In this script, we realize the Harris corner detection. First, we find the gradient of the image, and then we calculate the elements of the structure tensor and apply the Gaussian filter. Here we find the Harris corner measure. In order to define what a large value for the corner detection is, we pick a threshold for choosing corners. In the corners, we find the local maxima and exclude the points on the borders. Finally, we plot the output image with detected corners, as well as the gradient intensity in both directions. We can see from the gradient plot that these lines correspond to the vertical and horizontal lines in the image. The algorithm detects a corner where these lines intersect. As you can see in our image, all the corners were detected. Now let's say we wish to identify the corners in this picture in order to find the location of the windows on the wall. By using the same algorithm, we see that all the windows were found. This information can now be used, for example, to detect similar features in other pictures, or it can be used for object recognition.